Hi guys, so we're going to talk about parent functions and transformations. So let's just go through some of the functions that we're going to talk about. Really, we're going to use just the four, but I'm going to go through six of them altogether, the pretty common ones. So the first thing you have here, number one, is the constant function. So f of x is equal to some constant value. In this case, it is 2. Number two is the identity function, which is just y is equal to x, so that's linear. Then we have the absolute value function, so f of x is equal to the absolute value of x, which gives us a v-shaped graph. Then we have f of x is equal to the square root of x, which starts at 0, 0, and goes on, so our domain is only from 0 to infinity. Then we have the quadratic, which I'm sure we're probably all familiar with. So f of x equals x squared gives us a u-shaped graph. And then the last one that we're going to deal with is the cubic function, f of x is equal to x to the third. Now, what's important on these functions is being able to identify some of the points, like in the quadratic here, you have these points that we're going to use to actually shift the graph, left, right, up, or down, or a reflection in the x and the y. So that's really what you want to be able to identify, some of those key points, like here on the cubic function and so on. So let's go ahead and take a look and start with the first types of transformations, which we're going to have a vertical and a horizontal shift. All right, so let's start with the vertical. So you can see here and here. So what we got is f of x plus c or f of x minus c is going to give us an up or down shift. And it's going to have an up or down shift c units. Notice that the c is outside of the function value. In other words, it's the function plus c or the function minus c. And that we're following the actual sign of c. So if we're going to shift up, it's a plus c, and then a downward shift is a minus c. So again, we're following what the sign is for the c value. So f of x plus c is a shift c units up. F of x minus c is a shift c units down. Then we have the shift horizontal. And notice that the c value is inside of the parentheses. F of x minus c or f of x plus c. That is going to give us a left or right shift of the function. But you got to be careful because we're actually going in the opposite direction of the sign. Notice we're going to the right, but this is a minus c. Going to the left, this is a plus c. So in essence, we're going to the opposite sign in terms of the shift. It's the opposite sign, and that's the way we're going to shift. So if it's a minus, we're going to the right. If it's a plus, we're actually going to the left. So just pay attention to that. So let's look at the first examples here. Now what you'll notice is in the red, I have the parent function. So f of x equals x squared right here. That is the parent function of this function that we've shifted. F of x equals the absolute value of x plus 2. So I did that so we can see how are we going to get this function. Well, remember the plus 2 means that we're going to shift 2 units up. So each one of these ordered pairs, let me just change the setting here. Each one of these ordered pairs is going to be shifted up 2. And that is how we get the graph of the absolute value of x plus 2. So again, we took every one of the points of the parent function and we shifted it up 2 units. And that gave us this graph here. And here are the points that we shifted up. So now let's look at the square root of x minus 2. That means we're going to shift the parent function, which is in red here. F of x equals the square root of x. That's the parent function. We're going to shift all those points down 2. So I have these 2 that I highlighted, and they're all going to be shifted down 2 to get the square root of x minus 2. All right, let's look at a left-right shift. Notice how the C value is inside the parentheses now. So that's going to give us that left-right shift. So in red is our parent function. So f of x equals x squared. So we're going to take all of these points and we're going to shift them to the right. It's the opposite sign. So it's going to go to the right. So those values are right here. And you can see that that gives us this graph in blue. The absolute, not the absolute value, it's x minus 2 squared, okay? So now we have x plus 2 cubed. So this x to the third is the parent function. That's what's being shifted. And because it's a plus 2, we're going to shift to the left 2 units. So I'm taking these points, and they're all going to shift 2 to the left to get the function f of x equals x plus 2 to the third power. So let's look at a different type of transformation, which would be a reflection. So we have f of x equals negative f of x. So negative of the function, that is a reflection in the x-axis. And then we have f of x equals f of negative x, which is going to be a reflection in the y-axis. So you got to be careful with that when you see the signs, the negatives on the outside here, the negative is in the inside. So let's take a look at number 13. You can see the parent function, which is f of x equals the square root of x. And we're reflecting that over the x-axis because the minus is on the outside. I should probably use a different color because I used the yellow for that shift. So it's on the outside, so it's going to be a reflection over the x-axis. So all of these points were reflected over the x-axis to get that function. Now you can look at it this way in terms of the reflection. If you have your original, which is x comma y, a reflection in the x-axis is going to give you x comma negative y. So we have here, this point is 1 comma 1. That is the parent function. And then this point would be 1 comma negative 1, which is the reflection over the x-axis. Okay? So let's look at 14. So now you can see that we have the negative inside. The negative is inside, so it's f of negative x, and that is going to be a reflection in the y-axis. So again, we're taking these points, and they're going to be reflected over the y-axis. So in terms of looking at your coordinates, that is going to be x, negative x. Sorry about that. Fix that. Negative x, comma y. So these points are being reflected over to y. So if I had this point, which is 1 comma 1, to get to this point is negative 1 comma 1 if I am following this pattern right here. So again, it is taking the parent function, which is f of x equals the square root of x, and it's being reflected over the y-axis. So those are all rigid transformations because they're basically just shifting the graph, but the basic shape of the graph has not changed. So now we're going to look at a rigid, non-rigid, transformation, and that is going to be right here. So if we take and we multiply the function by c, now that is going to change the shape. It's going to distort the graph. It's either going to be wider or narrower. So if your c value is greater than 1, it's going to be a vertical stretch, which is narrower than the parent function. If your c value is between 0 and 1, it is going to be a vertical shrink, which is going to make it wider. Now, when you're looking at the value of c, you're really looking at the absolute value of it, because if the c value is negative, really negative tells you something different. The negative tells you that it's going to be a reflection in the x-axis in the front, but the c value itself will tell you whether it is going to be wider or narrower. So in other words, like here for number 16, we have 4 times the absolute value of x. If I had negative 4 times the absolute value of x, this negative tells me that it's going to be a reflection, but it's just this value here. The 4 itself is going to tell me whether it is wider or narrower. We don't say the negative 4, and that means negative 4 is less than 0. We don't have that. If you notice, that's not even here an option. It's either greater than 1 or between 0 and 1. So the C value has to be has to be positive that you're looking at. I just wanted to point that out. So let's go ahead and take a look at this first one. So we have f of x equals 4 times the absolute value of x. Well, this is our parent function. The absolute value of x is our parent function. So what we're doing is the 4 is greater than 1, which means that it's going to be a vertical stretch. It's going to be narrower compared to the parent function. So what you would really do is you would plug in your values that you have here and then figure out what the y value is. So let's say at 1, this point here is 1, 1. Well, basically, if I'm getting the new point, I'm plugging in 1 for x. So 4 times the absolute value of 1 is 4. So that would be 1, 4. So that's where we get this point on that function. And of course, to go in the opposite direction, it would give you this point. So you would just take these points here and for the x values, plug them in, and that would help you get your y values, which would get your new function. And of course, again, this is a vertical stretch because the c value is greater than 1. Then number 17, here is a parent function, absolute value of x again. But now you notice that the c value is 1/4, which is between 0 and 1. So that means that we're going to have a vertical shrink compared to the parent function, which means it's going to be wider. So you could do the same thing that we did in number 16. So this first point, 1, 1, if you were to go ahead and plug in 1 for x, it would be 1/4 times absolute value of 1, which is 1/4, which you can see is over here. If we pick a point that will work out evenly, like 4, so here you have 4, 4, which is on the actual parent function. And then if you plugged in 4 for x up here, 1/4 times the absolute value of 4 is just 1, which is this point here. So you can see how they transform to get the new function with that transformation. All right, so hopefully this will help you with the the parent functions. Also, don't forget that you can have multiple combinations. So let's say that you had something like f of x is equal to the square root of x minus 1 and then plus 2. Well, what do we have here? Inside the parentheses is the minus the c value, and here's at the outside is a plus. So this would be a shift to the right 1 unit, and then it would be a shift up 2 units. So you can have, of course, multiple transformations. Most of what I did was just one to show you how to do that, but of course you can combine them. Well, again, hopefully this helps you with the parent functions and knowing how to transform them based on a rigid or a non-rigid transformation. And I will definitely see you next time.